topic tonight is GPU support. First of all, a little bit about Clarifai. We are a startup in New York. We do machine learning. I'm going to be very brief about this. We have an API to process images and videos, and we use GPUs for that. We use pre-built models, also custom models for special customers, but also you can make your own model using our API. We have a number of investors, including NVIDIA, I know, and I mentioned that because we'll be talking about NVIDIA. It's not, it's a coincidence. It's just the fact that most people in the machine learning world are using NVIDIA hardware, but this is just my disclaimer. Let's see. Who's using GPUs? I'm curious. In production. Well, NVIDIA people. So I like to divide workloads in two broad classes. First of all, there's probably the classic example, render farms. Let's say Pixar, you render a movie, so you're running GPUs for hours, days on end, or maybe you're training models for machine learning. The other use case is what I call the real-time online example, where you use a machine learning model to make a prediction. So during training, you use millions of images to train the model, but then later you just feed the model one image, maybe two, maybe 10, but a much smaller amount of data that goes in. About our workloads, as I said, we fall into those two. For the training case, we process millions and millions of images, and we still run this on our own hardware because hardware in the cloud is not as powerful as it needs to be, and we don't run Kubernetes yet for a number of reasons. In production, once we train those models, we actually do use Kubernetes on AWS. And here, as I said earlier, we have smaller amounts of data going into the model, and the operations usually complete in the order of milliseconds. Also, the traffic going into the API is very variable. During the day, for example, there might be more users, at night there might be fewer. Also, different models have different patterns as well. This will be relevant later. A little bit about our infrastructure. We used to run on virtual machines, and it was kind of painful. For example, if we had to add another instance of a given model, we would have to deploy all the machines because we would pack everything in advance. And then we'd have to transfer traffic to the new machines and shut down the old ones. Even a small change would take a few hours to deploy. This was before I joined. And the infrastructure was developed when the company was just a couple of people in a room, and it served its purpose at the time, but it didn't scale anymore. So I was hired to work on new infrastructure. So we were going to have Kubernetes containers, discovery, so that you don't pre-allocate everything in advance, and no more virtual machines. So everything was good, right? Well, it turns out that in practice, things were not as great as, they were good, but they were not as great as we needed them to be. More specifically, there was no GPU support, there were a bunch of other features missing. So given that nobody else was working on them, I started doing exactly that. And we'll be talking about the first feature, GPU support. So how did it all get started? Last year, around this time, I was in San Francisco. There was KubeCon, and I stopped David as well as Eric to ask about GPU support, and things just magically happened, right? Yeah. So that was just the beginning of a conversation that took several months, and we went back and forth over a bunch of proposals. I had some very aggressive ideas, but the problem is that you cannot just add objects to the API in Kubernetes without risking to break stuff later when you inevitably have to change them or even remove them. So we had something that I called V0, which was very limited, and it's been in Kubernetes since 1.3 from last July. So as I said, it's very limited. So what are those limitations? First of all, you can only have NVIDIA hardware, because as I said, that's a prevalent standard in in the machine learning world. You can also have one device per node only, and this is all statically configured, so you cannot even detect hardware. You have to do the work yourself on the machine. You can even tell what kind of machine is on, what kind of card is on the machine. Also, there is no resource usage reporting. And last but not least, the resource name is very long, as you can tell. It's a fully qualified name. But wait, there are more limitations. You need to set up the nodes with the right drivers and also the associated libraries. Also, there is a limit. There is a requirement that if you run a specific version of your CUDA, your code built against a specific version of the CUDA libraries, you need to have a specific version of the driver or higher. So right now there is no check for that, and if there is a mismatch, your container will crash with a very unhelpful message. So you still want to do it. All it takes is these 3 steps. First of all, you need to run the kubelet with a special flag. You can tell that it's highly experimental, so you use at your own risk. Second, as I mentioned, you need to expose the low-level libraries associated with the driver into the container. And third, you need to add resource limits and requests to your pod definition, to your pod template. And this is what it looks like. So on the left side, I have resources. I don't know if you can see the pointer. This is a subset of the whole YAML file you would use for your container. And then on the right, we have the volumes. You can tell that, for example, the tag here is, this is going to be very distribution specific. We use, for example, we use CoreOS, and on CoreOS, most of the file system is read-only. So there's only a limited set of locations where you can put your own libraries. So /opt is where we did that. This is a problem because now I cannot share this YAML file with anyone in the crowd here, because you would have to copy the libraries in the exact same place that I did, and that's not a given. So,
do these containers have to be privileged because they have to interact with GPU hardware?
There is no check at all. So the question is, does the container need to be privileged? Right now, no, because the support is experimental. It needs to be enabled by the administrator. So the assumption is that the environment is under the administrator control. So there is no check at the moment, but we're definitely going to do that and more in the future. So with all these limitations, with all these issues, we still did it because for us it was a huge gain in terms of productivity. So what are the next steps? There is a PR that probably will land in 1.6 where we will detect the GPU for you, so you don't have to specify the magic flag anymore. Also, in our case, we have a mixed set of configurations in the cluster, so we need to be careful to only enable it on machines that do have the cards. So this will remove a lot of that extra work. Also, with the new code, you can detect more than one GPU on a machine and assign pods accordingly. The new code uses an abstraction for GPUs, but it's still tied to NVIDIA for now. We also have ideas about how to improve this in the future, but for now, there are complications around the way the NVIDIA code is developed, which is using native code. In terms of better scheduling, the next talk will address that. There's something called node feature discovery, and it makes a lot of sense to have, for example, the vintage of GPU on your node exposed as a label on the node, so you can schedule on a more powerful card versus a less powerful one. We will also like at some point to be able to specify that we want two GPU cards. There are not any random two ones, but also two GPU cards that have a very fast link between that, because not all the GPU cards on the same machine will talk to each other at the same speed. I'll skip the scheduling. As I mentioned earlier, setting up the pods is tricky and not very portable. So we need to avoid encoding host directories in the pod, and also we need to give more helpful messages when the low-level drivers don't support your container image. There is a PR to support a plugin for Docker that takes care of some of that, but the main problem is that it's tied to Docker. If you use Rocket, for example, it might not work for you. So one of the ideas we discussed last week at KubeCon was to have an emission controller. An emission controller looks at an object right before it's persisted. So it's been authenticated, it's been authorized, so we know that that object can be created, and we can still make changes to it before it gets persisted into the Kubernetes object storage. So in this case, what we would do would be, first of all, check if the driver on the machine supports the particular container, and second, we can modify the volumes that the pod uses so that we automatically export libraries into the pod. That way, you don't have to hard code anything to YAML, and this setup is only needed once per cluster. We also know that we need better resource management. For example, we are a Datadog user, so we've been talking to them about getting more visibility into how many cards are in my cluster, how many are getting allocated at any time, and so on. Plus, we want to have multiple vendor support in that, for example. Yes, as I mentioned earlier, we have models that have variable amounts of traffic. Also, they come in many sizes. We have very large ones and tiny ones. So what we like to do is share the device among multiple models. This is possible because more than one process can talk to the same GPU. They will just get usually serialized. The problem is that you want to have enough memory to accommodate all the clients. At the moment, we pre-compute that, but in the future, we would like to have some kind of soft reservation where you say, I want to have 2 gigabytes of GPU RAM, and someone else comes in, they want 4, and if your card has only 6 gigabytes of GPU RAM, then no one else will be able to join. And there is a big caveat. There is no enforcement on the device. So if your GPU code is misbehaved, you will see crashes or worse. So you should only do something like this if you each model trusts the others on the device. How can you help? So if you're a GPU user, you should definitely participate in the discussions. Last year I was the one that started everything, but it was great to hear more people. Actually, I met a few last week in Seattle, and if you can make your voice heard, that would be great, because that way we have a better idea of what people need to do with the Kubernetes cluster in terms of GPUs. If you can contribute code, that's even better. And you can ask me later if you want, but we also have a system to automatically build NVIDIA drivers for OS, just in case it's something that is tricky